Picking up where we left off at, we will multiply the numerator and denominator by the conjugate. So now we have 6 times the square root of 6, which gave us 6 square root 6, and 6 times a negative square root 3 will give us a minus 6 square root 3. That will be our numerator. Now our denominator, square root 6 times square root 6 is the square root of 36, and a positive square root 3 times a minus square root of 3 will give us a minus square root 9. So we have 6 square root 6 minus 6 square root 3 all over square root of 36 is 6 minus the square root of 9 is 3. Now, what we have here is this here. We will have 6 square root 6 minus 6 square root 3 all over 3. Now, if you notice here, this 3, if we look at the numbers that are multiplied to the radicals, we have 6 and 6, and 3 goes into both of these. So we could divide all 3 of these values by 3. Now, if we divide this 6 by 3, this will give us 2, and that'll be square root 6 minus 3 goes into 6 twice, 2 square root 3. And this will be all over 1. Because remember, we're dividing each one of these by 3. I'm going to have to utilize this next page. So what we would end up with is, what I wrote here was 2 square root of 6 minus 2 square root 3 all over 1. Now we know anything divided by 1 is itself, so it'd be 2 square root 6 minus 2 square root 3. And that will be the final answer. Now, we scroll down here to section 8.5. It says here, solve the radical equation. We have the square root of x is equal to 2. Now, in order to solve this, we must square both sides because we need to get rid of this radical. Square root of x squared, we know, gives us x, and it's equal to 2 squared is 4. So this is telling us that x is equal to 4. If you put 4 in for x, the square root of 4 is 2. And it says here, to solve the equation above, we square both sides. What happens when you apply the same technique to the equation? Square root of x is equal to negative 6. So we have square root of x, and we square both sides. Then we will have x is equal to 36. Now, if we took this equation and we put in the square root of 36, we know the square root of 36 is equal to 6. But it also equals negative 6. But when we have the problem set up like this square root will not give us a negative 6. We're going to get to problems a little later where you will get that negative 6 answer. But this would not work. So, this is what happens here. It says, consider the equation x equals 3. Squaring both sides gives x squared equals 9. What are the solutions of the new equation? Now, if we had x squared is equal to 9, if we took the square root of both sides, the square root of both sides will give us the square root of x squared is x, and the square root of 9 is 3 or negative 3. So when we take the square root of both sides, we could get both answers here. So what we would need to do is we would need to take these values and go back to the original problem and see if they actually work. So we're going to go down here. It says, for this reason, we must always check proposed solutions in the original equation when we square both sides while solving. Number 1, if necessary, arrange terms so that one radical is isolated on one side of the equation. Square both sides of the equation to eliminate the square root. Solve the resulting equation. Check all proposed solutions in the original equation. So let's take a look here. Now, we have the square root of x plus 2 is equal to 3. So we square, well, let me rewrite this. X plus 2 is equal to 3. So we would square both sides. Now we know squaring this here would just get rid of the radical. And we have x plus 2 and 3 squared is 9. So we subtract 2 on both sides and x is equal to 7. So if we go back here and substitute in 7 for x, 7 plus 2, let me do it over here. If we substitute in 7 for x plus 2, and that equals 3. So it'll be square root of 7 plus 2 is 9 equals 3. And we know the square root of 9 will also give us the 3. So the x equals 7 is your solution. Now, we scroll down here to example 3. Now, we have a square root on both sides, but we still start off the same way we did the other problems. We would square both sides, and then what would happen here, we would have 3 squared, which is 9, and then we would drop this square root off, and we'll have x minus 1. We'll put that in parentheses. Equals, this square root and square would simplify out, and we'll be left with 3x plus 3. Now we'll use the distributive property here, which will give us 9x minus 9 is equal to 3x plus 3. Now we need to get our x on one side and our numbers on the other. So let's move the x's to the left. So we'll subtract 3x on both sides, and we will have 6x minus 9 is equal to 3. We'll add 9 on both sides, and 6x is equal to 12. Now we divide each side by 6, and x is 2. Now we have to go back to this equation here and substitute in 2 for x to make sure that it works. So we'll have 3 times the square root of 2 minus 1 is equal to the square root of 3 times 2 plus 3. So now we have 3 square root 1 is equal to the square root of, this is 6 minus 3, plus 3. So we have 3, the square root of 1 is 1, is equal to the square root of 9. 3 times 1 is 3, and the square root of 9 is 3. So this x equals 2 works. Now, one other thing I want to let you know, this is us checking. We just checked the answer. But you don't necessarily have to check it, but you should, just to make sure that it works properly. But the final answer here would be x equals 2. Now we're going to scroll down here to example 4. We have 4 times the square root of 2x plus 9 is equal to x plus 8. Now, what we need to do here, we still need to square both sides. But this is going to be a little longer of a problem than what we have been accustomed to with the previous examples. So we have 4 squared, which is 16, and the square root and square will simplify out, and we'll have 2x plus 9. And then, now we must take the x plus 8 parentheses squared. Now we know this breaks down to x plus 8 times x plus 8. Now we could do the distributive property here on the left, which would be 16 times 2x plus 16 times 9. And it equals 2. We have to do the distributive property of a binomial. So we have x times x plus x times 8 plus 8 times x plus 8 times 8. Now, we will have here, we will have 16 times 2x, which is 32x, and 16 times 9, which is 144, is equal to x squared plus 8x plus 8x plus 64. Now we need to combine like terms. So on the left side, it would still be 32x plus 144 is equal to x squared plus 16x plus 64. Now we need to subtract 32x on both sides. We will have 144 is equal to x squared minus 16x plus 64. And then we will subtract 144 on both sides. So now we will have 0 is equal to x squared minus 16x minus 80. I'm going to have to scroll down a little bit here. Now we need to factor this side here with this x squared minus 16x minus 80. Now remember, when we did the factorization, we did a times c. We know that, well, actually we list our a, b, and c first. A is 1, b is negative 16, and c is negative 80. For some reason this negative sign doesn't want to stay. So we'll take a times c, which will give us negative 80. Now we would do the factors of 80. We have 1 and 80, 2 and 40, 4 and 20, 5 and 16. Let me see, 6 dozen, 7 dozen, and 8 and 10. Okay, now, remember what I told you all before. When C and B are both negative, that means that the higher number must be negative. So, what we would do here is we would have negative signs for all of the higher numbers. So now when we add these up, when we add these numbers up, whichever one gives us a negative 16 is the two numbers we will use, which would be this 4 and negative 20, which would give us negative 16. So now we will have 0 is equal to x squared plus 4x minus 20x minus 80. We group the first two terms here, and we'll factor out an x, and we'll have x plus 4. We group the second two terms here, and we can factor out a negative 20, and we will have x plus 4. Now, we have 0 is equal to x minus 20, and also x plus 4. Now, we will set both of these parentheses equal to 0. So we have 0 is equal to x minus 20, and 0 is equal to x minus 4. So we add 20 on both sides, and 20 is equal to x. Then we add 4 here on both sides, and 4 is equal to x. Now we have to go back and check and see if both of these answers work before we declare that these are our answers. So we go back up to the original problem, and we're going to substitute in 20 for x, and then we'll substitute in 4 for x. And it just so happens that we have some room here for the substitution. So let's start off with the 20. So we have 4 times the square root of 2 times 20 plus 9 is equal to 20 plus 8. So we have 4, and under the square root, 2 times 20 is 40, plus 9 is equal to 28. Now we have 4 times the square root of 40 plus 9 is 49, equals 28. So we know the square root of 49, let me draw a little line here to separate this. We know the square root of 49 is 7, so it'd be 4 times 7 is 28. 28 equals 28. So we know 20 works. Now what we have to try next is 4. So, actually it'd be better if we put it over here. So we tried 20 and 20 worked. Now we want to try 4. I may have to go a little bit up here. Using this same equation, we have 4 times the square root of 2 times 4 plus 9 is equal to 4 plus 8. So we have 4 times the square root of 8 plus 9 is equal to 4 minus 8. Now, 8 plus 9 is 17, so it'd be 4 square root of 17 is equal to negative 4. Now, we know 4 square root of 17 is not equal to negative 4. So we know that our final answer for this problem would be 20, because 4 does not work. So, with that, this is why it is very important that you always check your answers, because if it doesn't work, then you have to make sure that that answer is X'd out. So we would get rid of the x equals 4, And our final answer here is x equals 20. And that's it.